Hello guys, welcome back to another video. This is Anirudh here, and today we are going to be learning about Monte Carlo simulation. So, Monte Carlo simulation is this sort of model that is used to predict the probability of a variety of outcomes that are possible when a lot of random variables are involved. So, let's say when you want to predict the price of a stock like Amazon. So, tomorrow, let's say Amazon's logistic business goes down, as in there is some problem in their, you know, the way they ship their products. Let's say it's down for 3 or 4 days. This will be a major hit for Amazon, and because of which there will be a lot of fluctuations in the stock price. So this is a variable thing. Like it could happen tomorrow, or you never know when it happens. Or let's say there is some internal conflict, or there is some sort of bribing or some illegal practice that a company has done, which gets revealed tomorrow, or there is some new tax policy. And there are a lot of variable things that could happen in the market. And in order to sort of predict all of these outcomes, the probability of all of these outcomes, we use this model, which is called as the Monte Carlo simulation. So generally, Monte Carlo simulations help us in understanding the risk and uncertainty involved while making decisions. And this is not only used in finance, but it can also be used in many fields like physics, engineering, uh, etc. And the main assumption of Monte Carlo simulation is that we assume that this is a perfectly efficient market. We are taking decisions with the help of all the available data and information, as in there is no information that is hidden from us, and we have access to every data possible, and all of these important data help us in making this decision. And that is what is the assumption over here. So we assume that we are in a perfectly efficient market and all the information is available instantly, and using this we can make predictions. So let me start by explaining the code that I've written here. So here we just import some basic libraries. And what we're going to do is we are going to simulate the possible returns of a portfolio of these five stocks. So I've taken Apple, Nvidia, Tesla, IBM, and ITC. So what we're going to do is we are going to download the data of all of these five stocks over the last 300 days, starting from so we just take the last 300 days before today, which is 10/3/25. So the last we download that data, and we call this get data function. So the get data function essentially downloads all of the stock data from the Y Finance library. I've already explained this in previous video. And out of all the stock data that you get, like there is closing price, there is opening price, there is adjacent price, but generally closing price is the most relevant one. So we just modify it to have the closing price, and instead of having the actual values, we just take a percentage change, which is a day-to-day percentage change in our returns. So we have these three key metrics that we take for every stock. So we take the returns, mean returns, and the covariance matrix, and we return all of these back to these three variables. So that is that. So I think returns and mean returns are fairly easy to understand why we need it. But let me explain why we need to have the covariance matrix. So the covariance matrix gives us this sort of takes all of the historical data, and it tells us how the price, due to the price of, let's say Apple went up. So covariance matrix would tell us how the other four stocks got affected. And if it was a positive, number, it would mean that they have a positive, relation. As in, Nvidia also went up. That is basically the thing about covariance matrix. Um, Covariance is basically used to evaluate a directional relationship between any of these two stocks. Yeah. And so when we are doing the Monte Carlo simulation, we don't want the data to have any NaN values because that would affect the simulation. So this is what our end output is going to be like. And we don't want anything to affect this because of NaNs. So we just remove all the NaN values. And now what we do is in always in a portfolio, um, we invest in different proportions, right? Let's say one stock is 10% of the portfolio, another is just 2%, another might be 60%. So what we do is we are going to randomly generate weights for our portfolio. So I've called the random.random, and we generate random numbers between 0 and 1. And then we normalize it by dividing it with the sum of these weights so that all of these sum to 1 and it is a proper portfolio. Okay. So let me just quickly run all of this. Yeah. So the first part is done. Now what we're going to do is we right now have the returns of each and every stock. We have the mean returns and the covariance matrix along with the proportion of all of these stocks in the portfolio. Now we're going to run the Monte Carlo simulation on this particular portfolio having all of these particular weights. So here we have just considered that we are going to run 500 possible scenarios that could happen. We are going to simulate 500 times just to know what all are the possible scenarios and for a time period of 100 days. So this is what is represented over here. We can also change this up to, let's say, 300. Since we have taken data from the last 300 days, we can also say we want data, we want to predict the future for the next 300 days, 500 times. And then we create another, matrix that is filled with the mean returns of all of these stocks. And we also want to store all of these day to day, let's say, portfolio value. So after every day the value of the portfolio changes according to whether the price of the stock has gone up or not. So we have to sum all of these, we have to sum up all of these stock values and then put it somewhere, and that is where this is where we put it. So this is called portfolio simulations. And we just initially fill it up with zeros. And as we progress, we'll just start filling it up with the relevant values and then we'll plot it. Okay. So we are considering, let's say, a portfolio of 10,000 rupees. And what we're going to do is we are going to simulate it 500 times. So we use a basic for loop for this. And here I've, introduced two special terms. So let me tell you about the significance of these terms. So first we have the Z term. And what we're trying to do is we are trying to get like random numbers that follow a normal distribution according to this size. Yeah. So this essentially is to generate, to introduce variability in our stock. So as I said, the market fluctuates a lot due to a lot of random variables. And in order to simulate these random variables, we bring in a factor called as Z. And this is able to show some variability. So let me write term for variability. Yeah. And okay. And the next term, the L term, is the it carries the historical data. So you don't have to worry too much about what this is. So this is just a Cholesky decomposition. So if you have ever heard of the LU decomposition of a matrix, so you know that any matrix can be split apart into an upper matrix and a lower matrix. And why do we do this? We do this because it is easier to store such matrices in the computer because it is computational. It's memory efficient. So that is the point. And what we have tried to do over here is we have just tried to take the lower matrix. Let me just show you how a lower matrix looks. So we'll have only the lower part filled. Yeah, so this is an upper matrix and this is a lower matrix. So only the lower part of the matrix is filled and the upper parts are, filled as zero. So this is the sort of output we get when we do a Cholesky decomposition on the covariance matrix. So this The lower matrix of covariance matrix carries the historical trends. So it gives you this sort of correlation, I mean, the covariance between all of these stocks. And then we have to calculate the daily return, right? So at the end of the day, what do we have? So daily return is nothing but, we have mean returns that we calculated over here for each and every stock. But then we have to introduce some variability towards it. But it shouldn't just be random, right? Even the variability should follow some sort of pattern. And that is the historical trend. So what we do is we take this sort of product between these two matrices. So we introduce variability in accordance to historical trends and add it to the mean and add it to the mean returns. So this is our daily return. And now we add this daily return to our portfolio simulations. So what we're trying to do here is we want to add the total value of the portfolio at the end of the day. So this plus one is just to, let's say this is the daily returns is between 0 and 1, right? And the plus one is to indicate it in, not relative percent, but absolute percent, like not 5%, but like 105%, right? And we multiply it with the initial portfolio to get the total portfolio value after that particular day. So we do this, 500 times for a span of, the next 300 days, and we store it in portfolio sims. And then, let me just run this. So we have portfolio sims, which has all of these simulations. We have 500 simulations for the next 300 days. And yeah, maybe, yeah, I could just show you how portfolio sims looks like and how Z and L look like. It might give you the last, uh, run output, but I think that's fine. Yeah. Can you see it? We can see all of these zeros over here, which is because of the fact that it's a lower matrix. It's just not, formatted properly, so I don't think we'll be able to see it properly. But yeah, and the Z is the, it just gives the shocks or variability. Let me check that and let's look at daily returns now. Sorry. Yeah, and this is the daily returns. So some days we get a small negative return, some small positive. So you can see that, because of the variability that we have introduced here according to historical trends, we are getting different possibilities. And we, let's look at portfolio sims now. Yeah, share. Yes. So yeah, now what we're doing is one particular simulation is that for the next 300 days, these are going to be the values. Turns out at the end, we are, ending at a profit of, let's say, 1,768 rupees or something. So you can see that sometimes it's going below 10,000, sometimes it's above 10,000. So we can introduce variability and, get the values. So we do this for 500 such scenarios, and then we try to plot it over here. And so this is our end product. And using this, we can see that the best outcome for us. Wait, let me just run this again. Yeah. Using this, we can see that the best outcome for us after, let's say, I think it was 300 days, right? Yeah. After 300 days, turns out the best outcome for us is around 35,000. And the worst that we could get to is around 5,000 rupees. So, looking at this, no, we could say that our portfolio is very well balanced and we have a very high profit percent, with respect to the loss, at least. Uh, and so, how is Monte Carlo simulation used in the field of finance? So, this is basically used by investors and financial analysts to evaluate the probable success of certain investments that they are considering. So, this is used mainly to price stock options. So, potential price movements of, the underlying stock is can be predicted using uh, this method, this model, and the results are then averaged and then discounted to the asset's current price to indicate the probable payoff. So that is there. The second one is portfolio evaluation, as I showed here today. The number of we can predict whether the portfolio will end up in a profit or a loss in the future, or if we have to have different strategy in our investments. And the third is fixed income investments. This simulation can also calculate the probable impact of movements in the short rate on fixed income investments such as bonds. So I would like to end this video by saying that the Monte Carlo simulation shows like a wide variety of probable outcomes for a lot of uncertain scenarios, and it is able to assign multiple values to uncertain variables and obtain a lot of probable results, and then takes the average of these results to arrive at an estimate of what the future could look like. And it 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 has applications ranging from investing to engineering, and it is heavily used in the fields of risk, especially to estimate the likelihood of a gain or a loss in an investment. And that's all for this video, and hope you guys enjoyed it. Thanks for watching.